Okay, this is the paleontological training for the Microsoft Data Center project. This is the data center location then and now. This is back during the Pleistocene era when mammoths and mastodons and giant bison were roaming this area. We're going to go through some of the fossils, geology, and the law around paleontological excavations. Paleontology is the study of fossils, and fossils are the remains or other indications of ancient life, including the Ice Age or Quaternary period. The fossils that are potentially found on this site are from between 11,500 to over 120,000 years old. Ice Age rocks and soils in the project area can be uncharacteristically shallow and can be more extensive at the surface than current maps would suggest. Significant Ice Age fossils have been found in the areas mapped as Holocene flood basin soils, and stream channel deposits within a half-mile of the Microsoft project footprint. There are federal, state, and local laws that regulate the protection of these fossils that we need to be cognizant of. California Environmental Quality Act, or CEQA, is the regulation that governs these sorts of things. Paleontological resources are explicitly afforded protection by CEQA, specifically in Appendix G, Section 5C, which addresses the potential for adverse impacts to unique paleontological resources, sites, or geological features. A key tenet in the CEQA environmental checklist is, would the project directly or indirectly destroy a unique paleontological resource or site or unique geologic feature? Under the CEQA law, the treatment of paleontological resources is usually conducted in accordance with guidance from the Society of Vertebrate Paleontology. California Environmental Quality Act applies to discretionary projects proposed by private or commercial entities, as well as state or local level agencies that require approval to determine if there are historic or prehistoric resources within the project site, and whether ground disturbing activities associated with the project have the potential to impact those historic resources. CEQA is intended to prevent significant avoidable damage to the environment by requiring mitigation measures. Some of those mitigation measures include site staff paleontological sensitivity training, such as presented here. The County of Santa Clara Regional has the laws CRC 49, which says that cultural heritage resources, which includes paleontological resources, within Santa Clara County should be preserved, restored wherever possible, and commemorated as appropriate for their scientific, cultural, historic, and place values. The City of San Jose also has laws and regulations relating to paleontology. Paleontology preserve and conserve significant artifacts in order to promote a greater sense of historic awareness and community identity is goals ER10. ER 10.1 require paleontological mitigation measures be incorporated into the project design. And ER 10.3 ensure that the city, state, and federal historic preservation laws, regulations, and codes are enforced, including laws related to paleontological resources to ensure adequate protection of historic and prehistoric resources. Federal, state, and local penalties are in effect. Violation of federal, state, and or local regulations that you're going to learn about in this presentation is punishable by civil and criminal, felony, and misdemeanor penalties, including fines and or imprisonment that could result in the revocation of project certification and shutdown of the project at the discretion of the appropriate lead agency. So these laws, regulations, and codes are super important. If a suspected fossil or fossils are encountered during construction, the construction work shall immediately be halted within a 50-foot radius of any potential find and notify the supervisor, project manager, and project paleontologist, who shall evaluate its significance. The area shall be cordoned off within a 50-foot radius, and all earth disturbance shall cease within that radius. Failure to report suspected fossils is a violation of federal, state, and/or local regulations and is punishable by civil and criminal felony and misdemeanor penalties, including fines and/or imprisonment. There is an obligation to protect and preserve at state, regional, and local ordinances. Project personnel have an obligation to protect and preserve scientifically and socially valuable paleontological resources. Violation of these laws presented above is subject to federal, state, and local felony and misdemeanor prosecution under these laws. All right, here is the location, of course, south end of San Francisco Bay, in the Alviso area between Highway 237 and 880, right in the corner there. Here's a little bit closer view of the site and its footprint, right there along Coyote Creek. All right, we're going to talk a little bit about the geology of the project footprint. Which geological layers could contain Ice Age fossils? The closest fossils near the site that have been found are from the giant extinct Ice Age bison and were found only about 1,000 feet west of Coyote Creek at a depth of 2 feet below ground surface in sandy soil. The most important rocks for discovering Ice Age fossils are the silts, sands, and gravels below the bay mud layer. These are the oldest, but they aren't always buried deeply. The dense interbedded gravels and sands appear to correlate to the fluvial, which is stream deposits, that separate the younger, non-fossiliferous Holocene Bay mud above from the older fossiliferous Sangamonian Bay mud below. Many of the borehole drill sites record sediments that could potentially contain these Ice Age vertebrates. Consequently, all layers underlying the project site and associated linears are designated as having moderate potential fossil yield classification class 3 for fossil discovery. Here's a geologic map that shows the different layers of geology around the site. This is a general map showing some of the layers. We'll get into some specifics of the site here in just a minute, but I want you to notice that this is the closest fossil site, the giant bison site, just west of Coyote Creek, virtually just within a few hundreds of feet from the project site. Here's a little bit closer up view showing the geology of the site in more detail. Here's Coyote Creek right here, and the giant bison site is around here. The project footprint right here includes 2 geological layers on the surface that we'll talk about in just a second here, this green layer and this brown layer, and some others that are nearby that are underneath. Here it is a little bit closer up. The QHL layers, the Holocene natural levee deposits, this green, and the QHFP Holocene floodplain deposits, this brownish layer. Underneath these 2 layers are these other layers and other layers that are submerged below these layers and potentially at the surface as well. Only 2 feet below the surface, there is potential for finding these other older layers that have fossils in them. Here it is showing the 2 layers on the project site that are most prevalent, and these yellow arrows indicate the layers that are found nearby. The Holocene stream channel deposits, flood basin deposits, and estuary bay mud. Remember, everything below that is going to be older and potentially containing fossils. And these layers are also potentially below the project site. Here are the drill borehole study that was done, all the boreholes that were completed for the project. Various of these borehole studies, this is a drawing illustrating what geological layers are found in a particular borehole. This one shows a well graded gravel with silt and sand right here at the surface. And so these layers, silt, sand, and gravel, are potentially fossiliferous. And so whenever this kind of a layer is found, sand, gravel, um, and clay, there is a potential for finding fossils in it. Here is a longer list of all the fossils that are found in the immediate area of the Microsoft project footprint. So there's many more than we've already shown. These are all Ice Age fossils. Most of them are vertebrates like giant mammoths, bison, giant ground sloths, mastodons, and such. Well, let's talk a little bit about the fossils that were found nearby. This is what a fossil mammoth tusk looks like in cross section. You can see the layers. This is all ivory. And this is at the Mass Science Nucleus Museum in Fremont. And this is from that museum. And it's about 13 centimeters in diameter, so a little longer than your hand, average size hand. Here's the layer of clay, dark clay, that some of these fossils can potentially be found in. Here's a close-up of fossilized bone. And this is what you want to look for. You want to look for these bones that have all these cancellation in it. These are called cancellae, right here, these holes. This is what a mammoth tusk looks like if it's been broken up by a big earth-moving device and rolled over. It's not going to look pretty. It's not going to look potentially like anything, but it does look like this light-colored, shattered ivory. And here's a little bit closer of that one end. This is the tusk of a mammoth. And this is what happens when a big earth-moving device hits this. It's not going to look all pretty. And again, here is mammoth humerus, the upper arm bone from a mammoth that was hit. And I want you to notice the color, the shape, the texture of this bone, because this is potentially what these bones are going to look like. This is about 2.5 feet long here, 50 centimeters. Here's a mammoth toe bone. It's about 10 centimeters long, found nearby. Here's the skull of a Columbian mammoth in a museum. This is what mammoth teeth look like. They have these cusps here that are used for grazing grass like a horse, and these are gigantic. They're you would need 2 hands to pick this up. Here's a couple more mammoth teeth showing what they look like. If you see anything that looks like this, immediately shut down the area and cordon it off. Here is a Ice Age horse jaw that was found nearby, Caltrans 680 site nearby. These giant horses, well, not too giant, but big enough, are found in the area from the Ice Age. Also found nearby, up north, is cave bears. These cave bears were gigantic, bigger than a grizzly. Here's what bone fragments look like. If you come across any of these in your workings on the site, bone fragments are extremely important. And again, if you see any of these, shut down and cordon off. Here's some horse bones and what they look like. These are leg bones here, and these are teeth. And these are all found in San Jose, north in the South Bay area. These are bison bones. These are leg bones here from bison and teeth from bison. Again, here's teeth, bison teeth and molars. This is a mastodon. Mastodons are also found in this area. And mastodons, unlike mammoths, were browsers, so they fed by stripping the leaves from trees near rivers. They didn't graze like a cow or a horse or a mammoth. And this is what they look like. I'll show you the teeth of a mammoth or a mastodon in just a second. But this is the size of the skull of these creatures. These are big elephants, big proboscideans. Here's a mastodon dig site showing what it could potentially look like with the mastodon bones spread all about. Here's the tooth of a mastodon showing what they look like. They're cusped, unlike the mammoth that has flat teeth for grazing. These have cusp teeth for pulling leaves off of trees near rivers, rather than out in the grasslands like mammoths. All right, let's review. This is what a fossil bone fragment looks like. If you see anything that looks like this, immediately shut down, cordon off, and call your supervisor. This is what a mammoth tusk looks like after it's exploded from being crushed by a heavy earth-moving equipment. This is what some of the soil could look like. This is silt, dark brown silty clay. You could also get sands and gravels in the area that also have Ice Age bones. And again, pay close attention to the texture, the shape, and the color of this bone here. This is a mammoth humerus, the upper arm bone, and keep this in mind when you're working. Okay, if suspected fossils are encountered during construction, the construction work shall immediately be halted within 50-foot radius of any potential fossil find and notify your supervisor, project manager, and the project paleontologist who shall evaluate its significance. The area shall be cordoned off within a 50-foot radius, and all earth disturbance shall cease within that radius. Failure to report suspected fossils is a violation of federal, state, and/or local regulations and is punishable by civil, criminal, felony, and misdemeanor penalties, including fines and/or imprisonment. All right, this presentation has been presented by Pacific Paleontology in Santa Cruz and Monterey. All right, that's it for now.